Okay, here's where this Tech 10 is coming from. I usually run HF, a lot of sideband, and back in the day I had a Collins S line. I got my ticket in '64, so I've been at this for about 50 years. And I got a linear, 30L1, some of you are familiar with that. Well, back in the day, the 30L1 ran 4 811s in parallel. And it was a great Collins piece of equipment, but it had a habit on 15 meters of doing some strange things that were out of band. So I got interested in, well, how do I know whether or not I'm getting in trouble with my linear running off my transceiver, my new transceiver? So what I came up with is a technique for you to take a look at what your linear is doing and know that you are in fact legal and you're clean and that other hams are not going to give you a tough time because of what's going on. And a key part of this is a piece of software that is absolutely free, and it is rather impressive. So I'm going to start out with the software, show you what it can do very briefly, then jump into how you hook it up to your transceiver and your linear, and we'll make this a quick presentation. Okay, this is the software coming up. It's Soundcard Scope. It's free. You can purchase it if you want to embed it in something you're developing. Otherwise, as a private user, it's free. What it is it's a combination scope, signal generator, Fourier analysis device. It does a whole lot of things. And this is the interface for the oscilloscope portion. It's 2 channels. All these colors are absolutely selectable by you. You make them what you want. We'll come back to that in a minute. We're going to go over to the signal generator. Here's the center signal generator, 2 channels, sine waves, trapezoids, square waves, and mathematically you can input a formula for a waveform that you would like to create. It will handle all that. And once again, you get to set the level, the frequency. You can turn the channels on independently. You can sum them, you can subtract them. You can do all kinds of analysis with them as a source.
Yeah, Jim, what is the frequency range of the...
This depends on your computer.
Okay.
It's going to use the sound card in your computer, and on my 8-year-old Sony Vaio, it's 44.1 sampling, and it's going to be limited to 20 hertz to 20,000. So it's basically an audio device. But to do a test for your linear, you need 2 audio frequencies. Most of the time you're going to use 750, and then you need another non-harmonically related waveform source for 750. So I'm going to put in here, I'll put in 750. I just inputted that. And I'm going to put in 1333, and I'm going to input that. And I'm going to turn these 2 channels on. Okay, there they are. You can hear them both come up. So I'm creating a stereo signal at those 2 frequencies. Okay, one of the things you can do is look at Lissajous patterns. Those of you that have played around with this, there you go. Those are not harmonically related signals, so you can see that they're rolling around. If I were to change the 1300 to 1500 to be a second harmonic of the 750, it would lockstep and stay solid. And by the way, you can change the phase in 1 degree increments between the 2 signals. It's that accurate. Okay? And again, you have control of all the colors. The yellow pattern could be any infinite color. There's 16 million colors you can make it. The grid on the scope display is 16 million colors. Each of the 2 channels is 16 million colors. You've got control of everything. That's what all these color bars are down here. So let's go back to the scope. And that's what the signals look like. They're a little hot. So I'm going to go back and I'm going to drop these down just a little bit. I'm going to make them, say, 0.35.
Can you sweep the frequency?
Can I what?
Sweep it.
I'm sorry?
Sweep it.
I don't think so.
Sometimes you can.
Yeah, which I don't know that you can sweep it. So what I did is I just lowered the level just a little bit. There we are on the scope. Like any other scope you would use or experiment with. Let me pull it out there. Here you go. Again, we have control of the colors. I'm going to take the channel 2. That's right there. That's the color palette they give you to start with. But if you really want to be, exotic about it, you can go to that many colors. There's your 16 million color palette that you can make the traces anything you want them to be. Okay, so those are our sources. We need two frequencies, not harmonically related, and now we're going to use these. And I'm going to pause this for a moment. So we don't have to listen to that. And let me get up our slideshow here from the beginning. Okay, so this is Soundcard Scope, a free piece of software to be used to check out your linear, and it's free, fine print, it's private use only if it's free. If you decide you're going to try and market it or embed it with something or sell it, you need to do the licensing and buy it the way you should. Okay, this is what their homepage looks like if you want to get it from the guy. Some of the features are just, it's amazing. I have a lab scope, 4-channel Tectonic high-end scope. And I put it up against this one by taking the output from, basically I took the output of my computer, ran it to a couple of cords into 2 channels on my scope. The frequency was dead on and the amplitude was dead on. I was pretty amazed. It was the 3 significant digits, it was exactly aligning with the scope. That's pretty impressive. By the way, I have these documents, several copies, so you can look them over. I'm not going to spend time going through them. There's an example of the Lucidue patterns and all the features. You set the trigger, you set the slope of the trigger, you set the amplitude of the trigger, you can delay it. On the oscillator side, there's a section for a wave file. You can record it. If you're doing something special, like you are taking the output of your HF rig, you can actually record the wave file if you want and save it for posterity. And it has all the normal features of a multi-channel scope on one-shots, single trigger shots, everything you can really think of, imagine. And this version is 1.46. It's very stable. It's been around for a couple of years, and it is the current version. So if you go to the gentleman's website and you want to go ahead and download this thing, you're looking for version 1.46.
You know if it's Java or will it run your Linux?
Yeah, I think it's C++. As far as the language was written in. Okay, here's what we're going to do with it, quickly. We've got 2 audio channels. The top one is 750, the bottom one is 13330. We're going to feed this into some kind of combiner or mixer because the critical thing is the 2 channels have to be exactly the same in amplitude. Okay? The advantage to all of this is all of that first 3 blocks are free in the software. You've got a mixer that you can control the frequency. You've got the full left-hand side of this diagram for nothing. Then you feed it in your HF rig. The poor man's way of doing that is to take a speaker, like we were hearing off mic, feed it in your microphone, key down your rig, you feed that signal straight in. The disadvantage of that is whatever the distortion is in your speaker and your microphone, you may be tampering with the legitimacy of what you're trying to do. It's just easy enough to take a 1/8" jack out of your laptop, for example, and feed that into a line-in equivalent on your HF rig. Okay, once you go into your HF rig, you got to come into your new linear that you just bought from ACOM or Americom or somebody like that. The smart thing to do is to take your linear output, feed it into a dummy load, so you're not interfering with your neighbors or other hams that are, on the band at the time. But you need a sampler. You need to pick up a little bit of that RF out, not much. And this is the part that gets to be tricky. That RF sampler can be very expensive. If you get a Bird RF sampler, it's $200. If you buy an RF sampler from some of the other vendors, it's about $139, $149. If you ever see one at a swap meet, jump on it if you can afford it, if it's a good price. A sampler is nothing more than a little box about that big, PL in, PL out, BNC takeoff. Or it could be an in connector in connector out, and a BNC takeoff. But that takeoff is what you feed into the scope. And what you're looking for are these patterns. The one on the left is a good to go pattern. If you'll notice, it has a sine wave shape. Now you're beating the 2 frequencies together, so what you're seeing is the beating of those 2 audio frequencies in your sideband setup. And you'll notice that the squelch point where they come together goes down to 0. That is an ideal pattern, and your rig is sweet. It is really doing a good job for you. So as I said, you've got a great response. It's 0. You have very low IMD, intermod distortion. and you got a great signal, you're going to get great reports. However, on the right, something's wrong. You'll notice it's flat topping, the shape is not sinusoidal at all. This is overdriving your linear. If you do this, you're going to splatter. You're going to get a lot of IMD. You're going to have spurious signals all over the place. And generally speaking, your audio is going to be distorted. So the guys that are listening to you or the gals that are listening to you may comment that you sound pretty ratty. That's one of the things that a linear can do if it is overdriven. ALC, that automatic limiting control, if adjusted properly in a rig, can sometimes help you to get out of this right-hand waveform over into the left-hand waveform, which is really what you want to do. So there you go. There's a really quick way of doing this. The first item up there is the gentleman who provides the software free. That is quite a service, I think. The ARRL handbook has lots of ways to do the two-tone test. W2AEW, if you haven't found this gentleman yet, he has over 100 videos on amateur radio. He is well equipped with gear, and he loves to do these little 6-minute videos on different topics. But without the attitude, yeah. And yeah. And then there's an application note that I brought a copy of, application note number 2. It shows the same setup. But anyway, that's it. It's a great way to check your rig out, make sure you're doing good. And again, hey, the cost is very minimal. And you can actually build that little sampler takeoff. W2 has a little video, 6 minutes, on how you can build your own. Costs you 4 connectors and a piece of copper double-sided clad PC board. I think it's 3 resistors and 2 capacitors. So if you want to build it yourself, you can do it. It's just not as fancy as the Bird unit or some of the other units. That's it. Tech 10.
Thank you.